1, 2, 3. Good morning. We'll start in a few minutes. It's not time yet, but don't worry. Hello, everybody. It's 11 o'clock. I see already part of the people joined, but still people are joining. So I wait maybe for 1 more minute before I start. And then we can talk about the topic, how to implement DataOps in your data warehouse. Okay, so I will start. Maybe still people are joining, but we will see they can participate as soon as they are here. So welcome to the webinar, Become Truly Agile Data Ops with the Datavault Builder. And we will have a look at how we will look more on the conceptual side, less on the technical side. And this should help you to get an idea how data ops could work as well. Maybe if you're having other tools, to just get the idea how we see it, which tools are there, how you can implement it, how to work with it, and which different kinds of data ops you can do. So let's start a little bit first introducing myself. My name is Peter Bellis. I'm working in the data warehousing area since 2000. I started with Inman data warehousing. I worked on Kimball style warehouses in finance and telecommunications. And back in 2012, I came across the first project where we needed near real-time warehousing. And we found out that during the time that we had and during the not finished business requirements, we were not able to complete that with a classical approach to data warehousing, means using an Inman or Kimball approach. So we remembered that some guy named Dan Lindstedt wrote something about Datavault. So we tried that out and implemented during 3 months a completely new data warehouse with not completed specifications, not completed source system, and managed to deploy all the solution for the rollout of new products for a telecommunications company. So they had a working fraud analysis data warehouse from day 1 on. And it convinced us very well, but we found out that without the proper tooling, without the proper methods, this whole thing is not working out. And since 2012, we are now working on the Datavault Builder, and together with it, how to become agile, how to become data ops capable. Good. So what is the Datavault Builder? Just a short introduction for all the people that were not joining any of our webinars before. We are a model-driven data warehouse automation tool. We are using primarily the ELT approach. and this unleashes the performance of analytical databases. So I will concentrate a little bit in these examples here on Snowflake and Exasol, but it doesn't mean that's the only thing that you can achieve. You can do the same with Oracle, SQL Server. We are as well supporting Postgre, but it's just like we'll give you some examples how this can work out in a cloud environment today. So which kinds of layers do we have? Which kinds of problems do we have that we need to support? And in a data vault approach that we are creating in a data warehouse, but you could use that as well for Inman probably style warehouse, just you would need a little bit of different tooling, is that we are loading the data from the source into our staging area. Then we are going into a core. We are not applying any business rules in here. That's the big difference to normal form warehousing. Then we are going into a dimensional model, means the denormalization. We're applying business rules. And the good thing is, if we have analytical databases, we can go straight out to the data mart without storing or materializing the results of our business rules back into our core. We need this sometimes for auditability reasons and sometimes for performance reasons. So we have the option, but still the better the database supports us in virtualizing, we can output the more out here. And the more we virtualize, the more agile we become, because exchanging a business rule means just replacing a database view in that case, instead of changing load processes and stuff like that. So what is the Datavault Builder supporting? It is supporting the full range from the source into the staging area, into the core, and as well out. So we're modeling everything within the tool. Implemented technically, it is all in your database. As I say, in this case, I will focus on Snowflake and Exasol, but could be as well other databases. And by having everything in one tool, we're having only one deployment process. This means we don't need to separately deploy database structures, ETL or ELT loads. It's everything controlled by the Datavault Builder. So everything that I'm talking about, it's including everything that you need. It includes as well master jobs. It includes schedules. It includes everything that you need to make your data warehouse operational. So why I'm focusing on these databases is all of these technologies are built for the cloud. And that's important because it allows us that we are not dependent anymore on infrastructure. We don't need to wait until some bare metal is ordered. And we can just start on from day one. We can set up as many environments as we need, and we can go further from there. Why do I like working with analytical databases? Because they were built to purpose. Yes, SQL Server is a good database and it's getting better and better. But still, the focus is that it's as well serving online transaction processing, and you can do some analytical workloads on it. But it's not mainly built with a focus on analytical workloads. And by focusing on analytical workloads, it makes them faster, but on the same, you lose the online transaction processing capabilities, which is fine if you use it for this purpose. And this allows us to create a lot of virtual layers. So everything behind the core data warehouse we can build using views, and we are making it that we are visually constructing the business requirements for these views, and our tool is translating that into working code. And why are we using the Datavault Builder? Because you could say, okay, if I have the databases, I could work right in the database, but the tool itself is giving you the model perspective. So applying, testing, and deploying changes takes you just minutes. You don't need to write manual code. You don't need to write some script. It's model driven. And what we deliver as well over time is we deliver you new patterns, and new patterns not only for new data models that you're creating, but as well for your existing models. So we are maintaining the patterns over time, and that is working because the tool is working on the model level and not on the technical implementation level. So how does this look like? You get a little bit of touch and feel. The tool itself is a visual tool where I can construct my entities. So I'm defining like my core business concepts, airplane, flight, and airline here in this small example that we have here. In a technical implementation, this core business concepts will become hubs, but we are not talking like this to a business user. We are talking about his business process and how he can solve that and what he needs to have in the data warehouse based from a business perspective. We have here relations. The relations on a technical level become link tables, but here as well, these are relations between core business concepts. We do have here the small dots, which are the satellites, where we will store the attributes, where we will do the historization. But again, the business user is just telling us which kind of information he has, what he needs to get stored, and not how technically this is implemented. You see as well, the tool is covering these layers that I explained before here in a proper workflow. It guides you through the whole workflow and then creates technical implementation in real time on the database. This helps us that we can calculate as well data lineage automatically, so you don't need to take care of that. It's automating your documentation, everything out of the box, available for you, and you can concentrate on creating the data model with your business users. And now we are talking about DataOps. Why is Datavault Builder able to do things differently and better than other tools? And it's based on a main approach to the implementation at all. Because if you are coming from classical modeling tools, assume that you're working with Irvine, with Power Designer. Usually you have a modeling tool, but as well, if you have other automation tools, they're working the same way because that's the classical approach, and you work against the repository. At some point, you press the button and it generates the stuff on your database. And this is fine. This works usually very well if you're in project mode. The problem is, as soon as you go more operational, and you will go more operational, because if you're going in the direction of DataOps, you don't have the separation anymore of development phase and operations, but it will become both at the same time. You will have the operations people, and maybe on the weekend, they have an issue on the production database and they will do changes directly to the technical implementation. And they need to do it, so I'm not blaming them. But the problem is, as soon as this happens, you have a disconnect between the implementation and your model. And if this happens, the next time you deploy your model to the database, you will override some changes, or somebody noticed before you override it and nobody updates the model anymore. The people start updating the database, and your nice process about being model driven through a modeling tool and deploy on the model level gets broken. And we experienced that really in a lot of projects. We started back in 2006 already working still with third normal form warehouses working this way. And it worked maybe for 1 year, 2 years, and usually after that, it broke down. And how did we solve that? To get really agile, we killed the repository. This means that we linked now the model and the implementation in real time. And that's working with modern databases, and that's very cool. This means as soon as we add here some entities in real time, the corresponding tables are created on the database, the corresponding ETL and ELT flows are created and defined in the database, and everything is stored in the database. The implementation is the basis of our data model. This means that this is not only one way, but this is two-way. And if you change something in the implementation because you have to, no problem. It will go back and update the model the next time it's resynced, which is at least daily, but you can trigger that more often. And this helped us to become really agile because it solved a lot of other issues. Because now it means we can take from your development environment one hub, deploy it into your test or production environment. The target environment will recognize that the hub is there. It will update the data model, so you get always an up-to-date model. It will recognize that this hub needs to be loaded. It will update the master jobs. It will update the schedules and everything. So this solution helps us that we can deploy the smallest bits of our code that we have, and that's what we need, that the whole system is working. This will allow us that we can merge data models. This will help us that we can deploy single stories between the different environments. So that's step one. Kill your repository, but still be model driven is one of the basis approaches to DevOps from our side. So How do we start? Because let's assume that you didn't do DevOps before or DataOps before, and you want to start out small. You're used already that you have different environments. And now what do you do? So the first step is, why are we doing that? And please keep that always in mind. Ask yourself, what is my target? Why I want to go in the direction of DevOps or DataOps, and what is the benefit for my business users? And if we thought about that, we came up with time to market. That's for us really important because we found in projects, if we don't deliver the data fast enough, yes, the business user can't decide fast enough, but there is a second problem. If the business user doesn't get the data from the data warehouse, they find solutions. We found servers standing below some user desks, running some click view scripts, whatever, and we're calculating some figures that were not in line with any other department. So time to market is important to get the data to the business user and to prevent any workaround solutions. Agility is another side of the same coin, but still it's different. Agility means that we are able to react, means get the data first there and then make it possible to change it. Because if we can't change it, if we can't change priority in which order stuff is developed, we would be blocked by delivering something early because we cannot change it anymore. So that's the second thing that we need to keep in mind. Third thing is auditability. I still, even if I deliver fast, need to be able to track what I did deliver, which change cost, which impact. Because if I'm delivering fast, I need to take into consideration that I maybe will deploy some business rules which were not completely correct, which I need to change later. So I need to be able to report on when I delivered this output and which impact it had to the business users so they can correct their views based on that. And the third thing is we need to reduce risk. If we had like 2 deployments per year, and I really started like this in banking, we were able to test a lot manually. So before every deployment, there was a phase, like a few weeks before we deployed, there was a freeze. You couldn't bring any new requirements in. It was finished. It was tested manually. If there was some features that were not properly working, they were removed from the deployment, and like weeks later you deployed. This is not possible with DataOps anymore. We are getting into constant deployment every 2 weeks. We have clients that are doing that every week. And if this happens, we need to be pretty sure that what we are deploying is working as good as possible. So let's start with a simple setup. And ITIL, which I recommend really to follow, is giving you instructions to at least to set up 3 environments. Yes, I'm not going into details that you can have more environments like pre-production, split test and UIT, that you can have different integration levels for your development box. But let's assume that at least you have to have 3 environments. And the classic approach is we're going from dev to test and to production. Straightforward deployment. What happens if a deployment is not working well? Probably we will have to have some rollback scripts or at least a path to reset the deployment. How do we manage that? Because we assume this is like a company, maybe a team of 2 or 3 people. They work in line. So even if they work agile, even if they decide what is coming into their sprint, they will decide at some point which stories go into test, and in the same order they will go into production. So it's pretty simple. We will compare the different environments. We will do, and that's what the tool is offering, on a logical level, not on the technical level. Compare the dev environment against your test. It will show you the differences, like which objects need to be created, which objects need to be deleted, which objects need to be modified. And now you can decide, and that's about defining your development process, is if you always select everything and say, okay, only the full state is changing, or you could select single elements which you want to deploy, like a single business rule or anything, and the tool is able as well to calculate the dependencies and include them in your deployment. So if you select this, you can execute it right away. It's using the APIs between different environments and roll it out. So to get into this level of simply comparing environments and deploying them. That's a thing of minutes. It's very simple to understand, but it has its limitations. Because as soon as you have like 5 or 6 developers and they all work on the same dev environment, you don't need which change is made for which story. So it's limited to what you can do with that. But it's a good thing to maybe start when you're starting a project. And maybe as well, what some clients told us when they're starting projects, what they did is they probably started with one environment, did like in the first iterations directly on the not yet live project on the production server, introduced in the second or third sprint the test and UIT environment, started development here and started deployment as well. And before the project went live, maybe in the fourth or fifth sprint, they set up the dev box and started this full cycle of deployment between the boxes. For me, it's very important. Please never go live with a project if you don't have at least 2 environments. We really recommend to have 3 because still the deployment is something that needs to be tested. So if you don't have 3 environments, you never tested the deployment before you go live, and that would be bad. Good. So that's a very simple method, built in, working out of the box, easy to understand, easy to follow. So what would be an extension of that? And the extension is we are now getting much more in a complicated setup, which looks like, why do we do that? And the simple answer is because we learned it from the Java people. The Java developers are working in an agile fashion and with agile tools now for more than 10 years, probably 15 years, the people I know, and they found that there are some approaches that you need to follow if you want to get into a controlled way and deploy fast. And what the idea is that we have an integrated development environment, we have test and production still, and again, you could have more environments here, but here we do have sandboxes. So every developer has its own personal sandbox. And before he starts anything, he's using the Git method to download the code to get started. Just a small thing, in the Datavault Builder, we are supporting that we just need to license the production server. So you can do this whole setup without any additional license costs. So the idea is that you download the state of your integrated development server to your sandbox, you do your changes, and you deploy them back. And this is not going directly, this is done through Git, because Git is a versioning mechanism able to work with local repositories and with a central one. It's a really big difference to SVN. I don't go into the details, but if anybody asks you, can you do all this agile stuff and DevOps/DataOps things with SVN? No, you can't. It's really completely different how Git works. If there are any questions, I can explain at the end. So after you deploy the integrated dev and your business user is happy or your technical tests are happy, you go into test and UIT. There you have the sign off by the business user that everything is working, probably with production data, and you deploy it. The advantage of this is that you could have developer A having started a feature today, and he maybe doesn't complete for 3 other weeks because it's complicated what he's doing. He needs more input from the business user. In the same time, tomorrow, developer B starts another feature, but he's finished within 1 day. And by using the Git method, you could let the feature developed by developer B overtake developer A by merging it earlier and going on from there. So what is the complicated part about this? One is the technical setup. I mean, to set up Git and whatever, it's pretty simple. You can open a Atlassian Bitbucket account within minutes. It is more about defining your business, your development process, and explain it to your developers. If you explain this process to Java developers, they say, yeah, fine, we're doing that for years. If you show the same thing to your data warehouse developers, they need to get used to it. So it's as well a change management project of explaining the people, documenting it, introducing them into this concept. So how does this look in reality? How do we create a sandbox? And here Snowflake has a very, very cool thing called zero copy clone. So you can go into your integrated dev environment, you type in like 2 command line commands, and it's cloning you the whole database. And because the Datavault Builder itself, it's not having its metadata repository, but it's reading the model always from the database, everything is cloned over. It means all the database structures, all the ETL and ELT definitions, all the jobs and everything is cloned with the database. So you just set up a new environment for a developer, connect to this target database, and it's working out. And the cool thing for Snowflake, it means you have a full data set, but you don't pay extra. Because they're not copying the data in reality, they're just copying the pointers over, and then you can do development and test on the full data set if you wish to. And that's a big difference to past implementations. If you try to do this with an Oracle database, you can, but you probably will wait for a bigger database. Ours here, it's usually done within a minute or two. So you're cloning, and which means we need to have a way back. And what we have here is this automated deployment path. And this can be either using the simple setup, or it can be using the Git setup. Now, how does this work with Exasol? Because Exasol doesn't have a zero copy cloning, there we are able to work with Docker containers. So we have the integrated dev environment as a real database. We set up here a very simple clone by starting up a Docker container. This takes minutes, is automatically configured with the Datavault Builder, but we now use the deployment process we are using in the other direction later as well to download the model and everything into your local database. And this process works as well with Oracle, SQL Server, and other databases. From here, the path back into your integrated dev environment, it's the same. This is now very abstract, and now I would propose that I show you an example how this can work out in reality. So, Git Flow applied in a very, very simple way. So let's put it that way. We have our master branch, which is corresponding, in our case, to production. We have here made a branch for integrated test, and on this we are working. And here we are branching off this and making for every feature that we want to develop, for every developer working on a feature, its separate branch. And that's important because that will be the basis that Git helps to determine what changed in this feature. And if you're maybe not used to the term feature, a feature usually corresponds to a story in Jira. So you would most probably, if you're working with the Atlassian tools, start a new story. From Jira software itself, you can start this feature branch. You will download it, install it into your local sandbox. Depending on if you have Snowflake, you would clone the database. If you have Exasol, you would import this branch into your local Docker sandbox and start your development. And here we see exactly what happened. Feature 4 was started as first, but it's taking a long time. So we need to merge it later. On the contrary, Feature 3 was started a little bit later, but it's not finished yet. Feature 2 was started as third, but was completed as second. And the last feature was finished first, but then there were changes made because it was not yet good tested, and then it was merged again. And only after stuff is merged here into integrated test and at least giving some reliability, it's going into the master branch. So how does this look in reality? Here I'm using Bitbucket. So we did, for a small sample demo that we did last week in a team exercise, create the feature branches for the features we are implementing. We installed it on local sandboxes, and now we had 2 developers, or 2 developer teams in that case. In fact, we had 4, but here the pictures of 2 teams developed different parts of our data model. So they were not aware of what the other teams were doing. They just did the changes based on their story. They committed the stuff back on their branch into the Git repository. They pushed it to the central Git repository. And what happens then is that we have a merge request. We have a pull request, sorry. And the pull request looks like that now We see from the dev branch, this feature was branched off, and now somebody wants to merge it back. And now we see exactly what did change. And this is here now how it looks like, the merge. And this is very, very different to the Git application of other tools, because we were aware of how this whole thing will work out. So for every object you have in your data warehouse, there is one single file. So you see exactly which objects they change. You see that there were two hubs added, the address and the customer, and a link was added from the address to the customer, and there were some configuration and version changes, okay? And then here in the details section, you see exactly this hub address in a human readable form, how it was added. And this doesn't work out if your tools are not built for this purpose, because they will have like binary comparison, which Git is not capable of, or they are not splitting your definition of your whole model into small files, which means that you will have every time one file changed with a lot of changes somewhere in between, and you will not have this clean view to merge your data models. So we did these merges, and we didn't do it just for the 2 teams, but for all the 4 teams. And that's what came out at the end, an integrated data model on our integrated dev environment working. And it was not just the models, as well all the corresponding loads were deployed together into integrated dev, and all the master job was integrating all the loads of all the different teams into one master job, because it's based on what it is implemented on the database, and that's this model here. And how complicated was it? The 4 teams that we had working on that had 2 hours time to create their model parts and to deploy it. They never worked with the tool before, and they were able to deliver it. Yes, we had some small fixes, and the part of the deployment was done by somebody knowing about Git. And at the end, it took, instead of 2 hours, 2.5 hours, but it was very, very fast to bringing people up to speed, to explain them what we are doing. And even with a tool they never modeled in before, they were able to model it, create a working implementation, and merge the 4 different teams together. And that's what DataOps is about. We can go slowly forward, and we have low risk of change. What would be the next step? Instead of doing that manually, you can go on and integrate it further. It's probably not the first step to do, but at the end, it works out that developers commit and push into a Git repository. You have a CI server detecting changes. It will start a build. In our case, as everything is container-based and virtualized, you can set up a whole new environment within minutes on your Docker host. It will report the results, and if the CI server is happy, it will validate the commit in the Git repository. This takes some effort to set it up in your company, and it takes effort to maintain it, to understand it, what it's doing, and then there will be next step. So if your commit is validated, is it deployed automatically to integrated dev, or is there some manual interaction? That are steps that you need to define for yourself. I can show you how it looks. For us, we are using Jenkins with Blue Ocean. That's an add-on to visually show the different parts. So if we commit something into a repository, there is a preparation phase. All the stacks that we need are started. And as we are developing on different databases in parallel, our tool, all the different environments are started. Then there is a little bit of cleanup, and then all our tests are run, and we go to the end. If there is any error in our deployment, we will see exactly which databases are affected. It will give us some detailed report. So we fix it, we commit again, and in the next run, it will show us that it completed correctly. We will validate the commit on the Git repository. The pull request can be merged into our integrated dev, and from there it goes on, and then it goes into a release branch, and from there it goes into test and production. So that's on a very, very high level how this whole thing works out. But that it's working, you need to have some different aspects, and that's like having a tool which is integrating all the processes into one tool. You need to have the support for this Git work that you model and your structures and everything is exported as one single construct, and that every object has its own file. And only with that you can get this all working in one view. And so what does it help you? We can use the power of the cloud to set up our environments, we save a lot of time, and we become really agile. And it's not only us claiming that. If you follow such a process, that's what BARC as well found when they analyzed different tools and compared this like to ETL tools like Informatica or SSIS, or as well other automation tools, found that you get better time to market if you use our tool and you follow the process. And that would be everything that I have here in my standard presentation. So I would be open for your questions, that we can as well go into exchange and answer specific questions. If you could type your question directly into the Q&A section, or because I think, okay, how did we set up the automated deployment? That's a good question, because that's something that we do, but we need to document better, and we will do that. And that's exactly why we're starting with this this webinar here to explain. The high-level explanation is we are using a CI server where we use Jenkins. Jenkins is connecting directly to our Git repositories. In our case, it's Bitbucket. It's waiting for a commit. As soon as the commit is detected, it will start this Blue Ocean pipeline. And Blue Ocean is not giving like new functionality, it's just orchestrating things better, making it visually better accessible. So in this first step, we will start on our Docker host server a new environment. So it's pulling the right version from our Docker repository, starting up the containers. When they are started, it's importing all the necessary structures into the containers. What happens then is we are running the tests, and the tests are run on 2 different levels. We are then executing them using Postman, because everything in the Datavault Builder can be triggered using APIs. So we are using the Postman application, running some tests on the API, like creating hubs, like inserting data, like loading data, and comparing it against expected results. The second thing with what we are doing here is running Cypress tests. That's probably nothing that you need to do, because you're more interested in the data outcome and not in the graphical user interface, but we are testing here as well if the tool itself behaves as it was behaving before. So we're adding more and more tests, like clicking in the tool itself using the Cypress tool, which is simulating a web user. But maybe you are still using this tool if you want to integrate the test of your report. So if you have like a web-based reporting tool, like some click tools, Tableau or Power BI, you could go to the web page in the reporting tool and look at the report that was generated and check if certain figures are working out there. And if the tests are successful, it's committed back. If the tests are not successful, we stop it and we manually need to check what happened and fix it. What we don't do, what I haven't included here, is then the step of automatically deploying a model. We are doing it here within the tests, but this is something we are doing using Cypress. So could you use SOAP UI instead of Postman? Yes, it's doing exactly the same, if I'm correct. I think one of our clients used that. If you can do REST calls there, and I think you can, then it should be possible, yes. One question is, if you could deploy just the database instead of using the model deployment. So if we go back to this step, so instead of using here the deployment, so copy the database or copy the database parts. Yes, it is working, because everything is in the database. And in the past, we did as well deploy this way before we had the automated deployment part here. we are not recommending that anymore because some parts of the logging is missing. There are parts missing of getting the stuff into the right logical order to deploy stuff. So if you just want to copy the full environment and deploy it, it would work. But then you would have the problem with the data. So even if the idea is working, it's not anything that I would recommend today. In a case of a special case that you want to deploy just one single object, you could do that, but please don't. There is a reason why we created in a very big effort, and we really spent some development time of more years than months into this, is because there are some challenges that are not captured if you're just copying the DDLs. Good. One more question I see. Could you deploy a zip file through a REST API? So that's a question from somebody that knows the tool a little bit. So if I'm exporting model, it's downloaded as a zip file containing all the separate files that we need. And yes, you can deploy, no, not through a REST API, but you can deploy it through the Cypress process. So using the Cypress process, you can use as well to deploy a zip file to an environment automatically. Good. So I would say a last question from my side is, who is already using parts of it? Who is using Git in his process, and who is using integrated deployment pipeline for all the part like ETL, ELT structures and the data model, and is already in this maturity level that I explained at the end? Okay, maybe too complicated question. You have the feature to raise hand. Maybe is anybody already using Git in his deployment pipeline? Only about 1/3. Okay. Is somebody still using SVN? Somebody, okay. And is somebody already happy with the status where he is? Nobody raising its hand. Hopefully you get there, and hopefully I could give you some input today. And if there are any specific questions, just contact me on LinkedIn, write me email. I'm happy as well if you're not using our tool to discuss such things, because I'm generally interested in this topic. What can be done better? How can we learn something? How can we improve things generally in the direction of going into DataOps? Good. I thank you, everybody. If there are no more questions, I would complete the webinar here at this point, and I thank you for your attention, that so many people stayed until the end, and looking forward to speaking to you. Good. Have a nice day. Bye.